I am Ashutosh. We design commercial grade air purification systems for large properties, for example, offices, hotels, airports, etc. Let me begin by saying that human beings are who are air quality sensors. We only measure or find out about the bad air quality when it has worsened beyond measure. So, particulate matter, which is a scientific term for dust, at sizes anything below PM 2.5 is undetectable by us. We can't find out. It only matters when it's already inside us and it's impacting us. So, indoor air risks are underestimated, obviously, because they are invisible. And we complain about temperature, we rarely complain about particulate load. So by the time air feels stale, the risk has already accumulated. And most indoor air quality failures are gradual. They are not dramatic. They just don't happen suddenly. PM1, and let me talk about that because it's one of the most harmful stages of pollutants that impacts us, including the ultrafine particles. They simply cannot be seen. Carbon dioxide rises slowly in sealed meeting rooms, which we don't detect. Humidity drifts before mold appears. VOCs spike without obvious smell. So, indoor air quality problems are systematic. They gradually seep in where we are present. Now, AI, what it does is it becomes a helping hand for us to measure and detect before it worsens for us. It becomes a powerful tool to analyze and measure what is going on inside an indoor air property. It tracks patterns, just not just values, which is the best part about it is that there is a pattern to when your indoor property gets polluted and what kind of pollutants are seeping in. It identifies abnormal slopes, not just thresholds, and it predicts risk before the discomfort settles in. So AI reads patterns, doesn't clean air though. It we have to be mindful. It is not going to clean our air. Now, the best part is we have AI examples to showcase, where we are using it right now in terms of solving indoor air quality issues. The one of the some of the primary aspects are particulate spikes follow occupancy cycles. So more people walk in, more people go out of a particular building, the spike happens because of the ingress of polluted air from outside. As one of the fellow panelists mentioned, we stay indoors for more than 90% of our life. So this fact matters a lot. The carbon dioxide builds predictably in sealed environments. Humidity deviation can signal biological risks early, and VOC spikes often follow activity or cleaning because we tend to use a lot of chemicals, harsh chemicals, to clean the surfaces, the carpets, and other such structures inside our property without being mindful that they are releasing VOCs, tremendous amount of it. So we can say overall, AI converts environmental data into operational decisions for us. Moving on, then comes the engineering layer. That's when the AI data, the AI, our faith in AI matters the most. So detection happens, that's the step one. Then elimination is where we come in. We measure what AI tells us, we analyze the data from the AI, we include filtration systems in building level setups that can remove particulate matters, carbon filters for gases, all the kinds of VOCs, humidity control through HVAC systems, and ventilation. A very disciplined form of ventilation modulation has to be mandated, and we ensure that that happens. You simply just cannot remove particulate matter and VOCs with software. Now, system level thinking is where it matters most. You cannot have standalone devices to improve a large commercial property, say an office area or a hotel. The standalone devices are just not going to work very well. They are maybe very good showpiece. Infrastructure engineering is what improves the buildings. If polluted air is recirculated, the problem compounds. It doesn't mitigate. Interception must happen before redistribution. So before we start keep recirculating, redistributing the same air plus some fresh air because it's mandated in commercial properties, there is no interception. The filters installed in the HVAC systems are for the HVAC system. It's not for the people. So those filters, including your split AC filters, your facet AC filters, are not for you. They are for the system, the infrastructure. So IAQ is a system problem. It's clearly not a device problem. Moving on, monitoring all these aspects of air quality parameters, it gives us make it helps us conduct an informed decision making in terms of the kind of filters, the kind of grade of filters, the setup, the alignment, the modulation, the capacity. All that can be configured based on the data analyzed from the AI data, which is amazing. We love that part where AI comes in and helps us do that. After that, the engineering comes in the picture. That solves the problem. It shows us what can be done if you have insufficient data. The engineering takes over, and that's where we come in. After recovering all the data, analyzing it, we integrate our systems inside the existing HVAC systems without making any infrastructure change. We ac- accept most of these buildings are being leased. The leases, the lessors, they are not really going to stay there permanently, and therefore they might move. And of course, the building owners, they 99% of times do not allow us to make any infrastructure change in the existing HVAC system. Therefore, since the past 9 years, we have designed and installed systems in about 15 lakh square feet all over India, where we have independent modulations of air purifiers that uses the HVAC system without touching it, without impacting the performance of the HVAC. Because you have to understand, a MERV filter which comes installed on the HVAC has much less pressure drop than a HEPA filter, which we use. And again, needless to say, HEPA filter encompasses all levels of purification in terms of particulate matter. Nothing, of course, comes close to HEPA filters. It's globally accepted. And we do recommend following WHO norms in terms of indoor air quality, which is much more stringent. It's not a guideline and it's not advice. It just shows that if you're maintaining below 5 level of PM 2.5, and of course, we are working diligently with the government officials, including India and outside, to make sure PM1 comes into the picture at some point, because PM 2.5 happens to be a larger dust, an outdoor concern. PM1 is what impacts us most. The research says higher accumulation of PM 2.5 ensures there is 50 to 70% of PM 2.5 is PM1. And if you just look into the impacts of PM1 has on our body, it's dangerous. It's not easy to get it out of your system, and that's where we make sure that we have optimum level of air quality maintained inside the building in terms of PM 2.5, PM1 up to PM 0.1, all the VOCs, and CO2. That's the optimum situation that any occupants can have, whether it's a private building or a commercial property. Invisible risk requires visible engineering discipline. I thank you for this opportunity, and I conclude my presentation here.